basically encapsulated within this, which is what you want. You want the inbound and the outbound transitions to be the same as what were shown for the superstate, and then the changes are all internal within here. So you create the tests for the higher level diagram first, and then you expand out the superstate into the substates, and then you either expand the existing tests to take into account the substates or generate some new tests to cover the substates. But the rule then would be the same, that every state needs to be visited and every transition traversed. Okay? And this is there's an arbitrary number of iterations that you can go through here, right? So there's no limit on how deep this can go. In each of these cases, the substates could also decompose down into a further set of substates. And for complicated applications, this might actually go fairly deep. Okay, so this allows you to deal with complex systems without necessarily having state transition diagram that spans 4 whiteboards, right? Now you still might cover 4 whiteboards, but with nicely partitioned ones that are comprehensible each to itself. Okay, now tables, state transition tables. And the nice thing about the diagrams is the diagrams show you in a nice graphical way what events can occur and how the system is supposed to handle those, both in terms of the action that it takes and the state that it ends up in. So that's nice, and it gives you a good visualization of what's supposed to go on. The thing that a state transition diagram really can't do for you is tell you what happens if an unexpected event or event condition combination occurs. What the diagram shows you is only that which is defined. It doesn't show you the error handling, if you will. Okay, well, errors can happen, right? And they have to be handled. So think of a lot of browser-based applications, for example. The way the parameters get passed from one screen to another is through the URL bar, the address bar at the top. You've just seen that, X equals this parameter, Y equals that parameter stuff at the very top of the address bar. That's editable. So conceivably, somebody, probably a hacker, could go in there and modify those and cause an unsupported event or event condition combination to be injected, if you will, into the system. So we need some way of forcing those out into the open so that we can at least have a discussion with people about what should happen in those circumstances. And the state transition table allows us to do that. The way that it does that is that you take all defined states, which you can see here. This is the list of the defined states. So we have 1, 2, 3, 4, 5, 6 defined states, right? And then we have a list of all of the unique event or event condition pairs defined here. So click link, that's 1, add to cart, continue shopping. Those are 3 events for which a condition never applies, so there's no condition specified there. Similar checkout. Now, login is a single event that has 2 potential conditions that can apply to it, bad and good. All right, so now our list is up to 6 because they're unique. Where Steve's getting his exercise here. Keep having a screen going blank here. Now, purchase, similarly, bad and good, right? Those are conditions that can apply. And then we get abandon, resume shopping, and go elsewhere. So we've got 1, 2, 3, 4, 6, 8, and then 3 for 11. Okay. So, excuse me, there are 6 times 11, or 66 possible combinations of states with events or event condition pairs, right? So what we do is we define a table that has 66 rows in it, and we methodically generate all of the combinations of events with, of states with event condition pairs. As you can see, excerpt here, we have browsing with click link all the way through browsing and go elsewhere, right? So that's the combination of this guy, browsing state, with this, and everything in between shown here, right? Now, based on the diagram, we can then populate the action and new state columns, this guy here and this guy here. Basically, if there is a defined action and new state shown in the state transition diagram, then we populate those here. If there is no such action and new state, then we show it as undefined. Okay? Now, at that point, we can go have a conversation with the system designers, requirements engineering people, business analysts, architects, what have you, and say, hey, what is supposed to happen in this undefined situation? Now, maybe they say, well, we have a default event handler set up such that if any event occurs, it's not expected based on the state, we pop up an error message that says, you know, your session has become confused, please go back to the home state, or something like that, right? The important thing is to know that there is some defined action, and then you could populate this table based on that defined action, right? If the response is, oh, well, don't worry about that, that can't happen, then, you know, as testers, you know what to do next. You try to make it happen, right? You don't just accept, oh, yeah, sure, that won't happen, because it will happen, right? Someone will figure out a way to make it happen. So brute force, you would go through and you would define test cases to try to force these things to happen. Okay, now you might or might not be able to actually do it, but you would try to force it to happen. So that would lead us to this derivation of tests to achieve row cover. Again, we have a set of tests that we created for state transition, based on the state transition diagram for the state transition cover, including the start-stop rule. Okay, so we've got a place to start here. Then what we do, construct the table, check that the existing tests cover all the defined rows, and they definitely should. If they don't, then you didn't define the table correctly, or you didn't define your tests correctly, one of the two. Something's wrong. So don't leave step 2 until you confirm that the state transition diagram tests cover all the defined rows in the state transition table. Then you wanted to take a test that visits one of the states that has an undefined row in the table. Copy that test, modify it to try to force the undefined event condition combination in that state. That covers the row. And then repeat steps 3 and 4 until all the rows have been covered. So this is a fairly simple process, but as you can imagine, with 66 rows, in this particular example, it could lead to a lot of tests. This is why it's very nice if the developers have actually thought about this, to find a default handler, because it's going to make your job a lot easier